Hi guys, welcome. Today we're going to create a pseudocode out of incremental search. So here's the function. This is implemented in Matlab and we're going to create a pseudocode out of it. So pseudocode is a human readable and non-formal or informal way of representing an algorithm. So it said here that we have a function here, inc search, with the parameters func, which is the function, xmin is the endpoints of the interval, xmin and xmax, and ns. So what this function does is first it checks if there are enough arguments. So check if there are 3 arguments, less than 3 arguments. So if yes, print error. So second, check if there are less than 4 arguments. So meaning there's 3 or lesser than that. Set ns to or equal to 50. Then next, initialize. By the way, we're following the code here. We're following what's being done here sequentially. So we're just following along. So first, this one, the if statement here. Second one, the other if statement. Then next one, this part. So set x as the linspace. I think linspace is a row vector containing values with equal intervals. As the or set x equal to vector row vector of equal intervals from xmin to xmax, something like that. The next, set f as the function of x. The next one, set NB to 0. So NB here, I think, is the number of brackets. Set NB to 0, 6. Set XB as an empty row vector. That will store the upper bound and lower bound of the kth sign change. Okay. Next, iterate from K, or rather, check if the sign of f of k is not equal to the sign of f of k plus 1. Then if yes, if true rather, let's replace yes with true. If true, okay, let's put this on another step. If true, increment NB by 1, or the number of brackets. 9. Set XB of number of brackets and 1 as the x of k. Then next, set xb of, so this xb here is our x brackets, nb of nb and 2 as the x of k plus 1. Then, because this is a loop, so we will repeat steps 7 to 10 until the length of x minus 1. Then step 12, let's go to this if-else part. So that will be check if xb is empty. If true, display no brackets are found. and check interval or increase ns, number of subintervals. Okay. 14, if false, display the number of brackets. And yes, that's all there is to it. Okay, let's put this on another line. Okay, so this is our pseudocode for the incremental root search function or algorithm. So there you have it. We have 15 steps, and we're going to try to implement this in another programming language. Okay, so now we're done coding. I tried to replicate the Matlab code as much as possible. So here, so we have linspace, function, and so on. So let's look through our pseudocode as well as our code. So first, check if there are less than 3 arguments. If to print error. We don't need to implement this in Python because it's automatically does it. And check if there are less than 4 arguments, set ns to 50. We don't need to check. We just need to set a default value. So if you set a default value in the parameter in Python, then you can omit this if you call the function. Omit the ns. Then next, we set x as the row vector of equal intervals from xmin to xmax. So that will be our linspace. So here in our Matlab code, we also have linspace. So it's almost the same. I converted it into a list because linspace produces a numpy array which I don't know yet how to work with. So I'll work with something simpler such as a list that can be accessed using numbers as the index. So we have our function set f, function of x, this part, then nb, number of brackets set to 0, we have it, set xb as an empty row vector, so that would be an empty list for us here. Then our iterative method here, so we need an iterative variable. We set it as 0 because Python is 0 index based. So arrays, lists, they start at the 0th element. In MATLAB, it's the first element. So that's the difference. So we have to adapt to Python standard. Then we'll use a while loop because for loops in Python is used for collections, collection access. So the best loop that will work for number-based access is while, in my opinion. So now we check if the sign of f of k is not equal to the sign of f of k plus 1. So this is it. So we use numpy sign method, and then if true, if it's not equal, we increment nb by 1. So it's this part. Then set xb of nb1 as the x sub k. So this is it. We just append it to the list and the upper limit as well. So xb of nb1 is our lower limit. So that's our x sub k. We append it to the list. Then we also append x sub k plus 1 to the list, the upper limit. Then we increment k so that it will terminate soon when it reaches length of x minus 1. So next, we check if xb is empty or our brackets, the lower limit, upper limit list. If it's empty, print display no brackets found here, and check interval or increase ns. So we printed it as well. If false, or that will be our else, print the number of brackets. So number of brackets, so that will be our count here. The count, how many number of brackets. Then we return the value. So now we try to run this function. So we have a function here, c cubed minus 1. So we called our incremental root search here with the function c cubed minus 1, and then start is 1 and end is 10, and number of subdivisions is 50. So it will check between 1 to 10 in 50 subdivisions. So we got here that we have one bracket, and the root probably lies between 1.0 and 1.183673. So now let's try another function. Let's say c squared minus 6 times c, or c squared minus 6c. Okay, let's try this. Okay, so this is our result. We have one bracket and the value lies between 5.95918 and 6.142857. So there you have it. We have a working incremental root search function. And how efficient is it to know the pseudocode in implementing an algorithm into different languages. It is efficient for a programmer to know the pseudocode because it allows the programmer to have an idea which steps to take when implementing it into another language. And also, knowing the pseudocode allows a programmer to measure the time and space complexity that the algorithm requires. So, how fast incremental root search will be, how slow will it be. Yeah, I think that's it. So, to conclude, we created a pseudocode out of, where is it? Okay, here. Out of this Matlab code, which happens to be the incremental root search. And then, we tried to implement it using Python. And we got a result. We have a working function. So I think that's for today. And I hope you learned something. If you do, please like, share, subscribe. And also, comment down below if you have a better way of implementing the root search algorithm in Python. And have a great day today. Bye for now.